This video is going to be an example of using the conditional probability rule. We've looked at the multiplication rule number 2. It looks like this: the probability of an event A and event B occurring, and we multiply these two probabilities together when the events are dependent on each other. This probability right here in this rule is called a conditional probability, because it is not just the probability of B occurring, it's the probability of B given that A has occurred. It has a condition with it that A has occurred. So this is the new probability of B given A has occurred. When we take this multiplication rule 2 and we rearrange it and put the conditional in the front, it's not a new rule, but we treat it as if it is, and we call it the conditional probability rule. So all we're doing is putting this rule in the front, and then we're doing some algebra so that we have the probability of A and B in a numerator, and then the probability of A, the event that has occurred, in the denominator. So here's an example of this. There's a probability that a student takes composition is 78% at a certain school, and then the probability that a student takes composition and speech is 64%. And now the question is, find the probability that a person takes speech given that they take composition. This given part creates this kind of conditional question right here. And so the condition is we're only looking at the people who take composition, and then we're trying to figure out, of those people that take composition, what's the probability they will take speech. So we're going to use this rule, and what we'll do is we'll take the probability of composition and speech over the probability of composition, and we'll just divide those. This is the probability of doing both composition and speech. That's this down here. And then this is the probability of composition, and that's this one right here. And so then we'll just divide those. I'm going to take 0.64 divided by 0.78, and I'm getting 0.82. Sometimes students will get this confused when there's a 64% chance of you taking both composition and speech. That's not the same as this. This is the probability of you taking speech. If it's known that you're taking composition, then there's a higher chance of you taking speech, because these are dependent events. You can answer conditional questions using a table also. And so this table I used in an earlier video. This is selecting a meal where you can have one drink and one sandwich. And so you can ask conditional questions off of this, like if you randomly select a person, what's the probability that they will choose a burger given they chose a soda? So this is a conditional question, and you can answer it by using the rule. And if you use the rule, the people who chose a burger and soda are these people right here. And so the top probability would be 15 out of 50. And then the people who chose a soda are these people right here. And so the bottom would be 25 out of 50. And when you do the arithmetic, the denominators, the 50, fall out, and you end up with just 15 out of 25. Or you could simplify that a little bit. You could make it into 3/5. There's a shortcut for this when you have a table like this. If you're asking a question like, what's the probability of burger, given you know they've ordered a soda, you know this, then you can just look at this row, knowing the 25 people who ordered a soda, and only look at those, and then of those 25, how many ordered a burger, And you can just go to 15 out of 25 and get this answer without using the rule formally. So I'm going to ask another question and we'll just do it with the shortcut. So what's the probability of you ordering a soda given you ordered a burger? Well, if you use the shortcut, you would be looking at only the people who ordered burgers. That'd be 30 because you know they've ordered a burger. And out of those, how many ordered a soda? That would be the 15. So the answer to this question would be 15 out of 30. Or you could simplify it and make it 3/5.